2 weeks ago, I uploaded a video where I challenged myself to solve 100 LeetCode problems. After finishing that challenge, I got busy and stopped for almost 2 weeks. Now it's time to continue. This challenge isn't about reaching 100 anymore. It's about reaching 200 solved problems in LeetCode. In my previous video, I focused mostly on beginner-friendly topics like arrays, binary search, sliding window, and two pointers. This time, things get much more interesting. I'll be tackling trees, heaps, backtracking, graphs, and a few other topics that looked slightly terrifying at first. This is what my dashboard looked like before I started. I occasionally solved the daily LeetCode challenge, so technically it says 104 here instead of 100. Close enough, so the challenge officially begins now. I picked up exactly where I left off last time, trees. Before solving any problems, I spent some time learning the fundamentals. There are two main ways to traverse a tree, DFS and BFS. Within DFS, there are three traversal orders, pre-order, in-order, and post-order. To make sure I actually understood them, I implemented every traversal myself in VS Code before touching LeetCode. After that, it was battle time. The first few problems actually went surprisingly well. They were almost direct applications of the algorithms I had just practiced. Then reality hit. The diameter of binary tree problem completely destroyed me. My solution looked correct, yet a few test cases kept failing. I spent a long time trying to figure out why, before discovering a visualization tool that let me actually see the tree structure. That tiny change made everything click. Once I understood what the recursion was really doing, I rewrote the solution. Accepted, huge success. The next obstacle wasn't much easier. I was solving subtree of another tree, and once again my solution failed on hidden test cases. At this point I made an important decision, a very important decision. For genuinely difficult problems, I allowed myself to read other developers' solutions after struggling first, not to copy them but to understand different ways of thinking. And honestly, that ended up teaching me far more than stubbornly staring at my own code for another hour. Eventually, I fixed my approach and solved it. After finishing several more tree problems, the remaining ones started getting significantly harder, so I decided it was time to move on. Next up, trie. A trie is a specialized tree used for storing strings efficiently. After implementing the entire data structure myself in VS Code, I was convinced I would breeze through the problems. I was wrong, very wrong. The very first trie problem humbled me immediately. I wrote nearly 50 lines of code, submitted it, and wrong answer. After several failed attempts, I stepped back and realized something. This particular problem didn't even require a trie, so I threw away the complicated solution, wrote a simple brute force approach, and somehow it passed. I'll happily take that win. The remaining trie problems were much closer to the actual data structure, so things started making a lot more sense for me. After wrapping those up, it was time for one of the topics I had been dreading the most, heaps. Learning heaps looked terrifying at first. Every implementation I found seemed ridiculously long, with dozens of edge cases. No, just look at this. This is like 100 plus lines of code. Fortunately, I remembered something amazing about Python. Python already has one built in. Instead of implementing everything from scratch every single time, I only needed to learn a handful of functions from the heap queue module. That made the entire topic much less intimidating. Problem after problem started falling, my confidence skyrocketed and my ego was pretty high at that moment. So naturally, I made the terrible decision to attempt a hard problem. 30 minutes later, I admitted defeat. Some battles are better left for another day. Still, after solving plenty of heap problems, I finished the section. At this point, my dashboard looked like this. It had taken me 3 full days just to solve about 24 problems. The difference compared to the first challenge was obvious, as you can see. These topics weren't harder because they required more code. They were harder because they required much better thinking and a much concise approach. Next up, backtracking. Here I will be honest. I almost skipped this topic immediately. Backtracking usually involves recursion, and recursion had never been one of my strengths. To make things worse, there were barely any easy problems available here. Almost every single problem here was medium or a hard problem. But avoiding difficult topics isn't exactly how you improve, and this is not in my mindset, so I committed to learning it anyway. After studying the core backtracking template, I solved my first problem. The runtime, let's just say nobody was impressed with it, but it worked. That was the main part of it, and that's what mattered to me, at least. Something interesting happened after that. Each new problem became slightly easier and much more manageable than the previous one. Patterns that originally felt impossible slowly became familiar because I realized one thing about backtracking problems. In backtracking problems, you don't have to come up with a completely different solution for each problem. You just have to study one core concept of it and you can apply that concept to every single problem related to backtracking. And before I knew it, another section completed, which meant only one major topic remained: graphs. Graphs felt somewhat familiar because many ideas carried over from trees. Still, I needed to learn several new algorithms before I could start. After watching a few tutorials and taking notes, I opened my first graph problem. And what do you think happened? Your predictions? Yes, I failed. Again. I spent over 20 minutes debugging before realizing my entire approach was flawed. After reading the solutions, I rewrote everything. Still wrong. Then I removed a few forgotten print statements. Accepted. Programming can be wonderfully confusing at times. Another graph problem gave me a different kind of headache. Every visible test case passed, the submission didn't. After several more attempts, I finally tracked down the bug and solved it. Slowly but surely, I worked through more graph problems until only the most difficult ones remained. By then, I had already solved over 150 problems in total. That's when I made what turned out to be the best decision of the entire challenge. Instead of immediately jumping into dynamic programming and bit manipulation, I went back. I revisited problems from earlier topics that I had skipped weeks ago. The difference surprised me. Problems that once felt impossible suddenly felt kinda straightforward. Most of them I solved on the very first attempt, as you can see here, and without realizing it, I had become a much better problem solver. For that final stretch, I focused on easy and medium problems from previous sections. Those last 40 plus problems took me less than 24 hours to complete, honestly speaking. That alone showed how much progress this challenge had given me. And with that, the challenge was complete. 200 LeetCode problems solved. But most of the problems were easy and medium, as you can see here. 125 easy problems, 72 medium problems, and only 3 hard problems. If there is one thing I learned from solving 200 LeetCode problems, it's that progress isn't about memorizing solutions. It is about becoming comfortable with being stuck and suffering. Every problem that frustrated me the most eventually taught me something I still use today. So if you're learning algorithms right now, keep going. The problems don't get easier, you just become the kind of programmer who can solve them all. In the end, I hope you found this challenge useful. Write in the comment section down below what kind of challenge you want me to create next. Other than that, thanks for watching and I'll see you in the next one.